Hi, Luke here from Technicamps for session 8 of the Introduction to Programming for Teachers course being run by Technicamps. Today's session is going to be our conclusion of loops. So we talked about while loops in 6 and 7. Today we're going to be talking about a little bit about while loops to give us a conclusion, but also something called a for loop. Okay, so the contents of today's session are going to be for loops, nested loops, which can be quite difficult, and writing them out by hand on a piece of paper actually makes them far easier to understand, so I would also suggest doing that today. And then we're going to look at a larger example of a while loop to calculate exam averages. So multiple students calculating loads of exam averages kind of all at once using some nested loops. So what is a for loop? The for loop can be used to iterate over the contents of any container, which is an object that contains or stores a collection of elements. So a string is a container that stores the collection of characters in the string. So on the left-hand side here, if we look at a while loop, we have the state name is a variable whose value is Virginia, start at I equals 0, while I is less than the length of state name, letter equals state name I, so it selects the ith letter starting from 0th, 1th, 2th, 3th, whatever, 3rd, 4th, and so on, indexes, prints the letters out one at a time, and then increments the counter here, this I counter, right? In the for loop version, we have state name equals Virginia. For letter in state name, print letter. Okay. So the important difference between the while loop version and the for loop version, in the while loop, the index variable I is assigned the value 0, 1, and so on. In the for loop version, the element variable letter is assigned state name of 0, which is V, state name of 1, which is I, state name of 2, which is R, and so on. Okay, so this in the while loop, we've got an index variable, which is being assigned a value 0, 1, 2, 3, 4, all the way up to the length of the state name. In the for loop version, we're actually, this is an element variable, and it's being assigned the state name at position 0, the state name's value at position 1, the state name's value at position 2, and so on. Okay, so a for loop can be used as a count-controlled loop that iterates over a range of integer values. So in this while loop version, we've got I equals 1, while I is less than 10, print I, and then we've had to increment I itself, okay, inside the while loop. In the for loop, for I in range 1 to 10, which is, a container of values going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, print I, right? And the for loop version, we don't have to increment it because I is iterating through a container of values. Okay, so how does the for loop work? A little bit more on the syntax. So using a for loop to iterate over the contents of a container, an element at a time. So you've got this container and you're iterating through that one element at a time. Okay, so for letter in state name, this letter is a variable, and it's set at set in each loop iteration. So each time we go through the loop, we set the value stored in this variable letter. In is a keyword, and then state name is the container that we're going to be moving through. Okay, so the variable letter contains an element, not an index. And then we have the loop body. The statements in the loop body are executed for each element in the container. So for letter, which would be the first element in the container of state name, then the second element in the container state name, and so on. So you can use a for loop as a count-controlled loop to iterate over a range of integer values. Okay, so in this example, maybe we're iterating through a string. So we've got a container of characters, which is a string. In the second example, maybe we're looping through a range of integer values. Okay. To do that, we're going to use something called the range function for generating a sequence of integers. Our sequence of integers is our container. And maybe we'll use the I kind of index variable that we're used to, but it's acting slightly differently to how it would work in a while loop. Okay, so we've got our I variable. This variable is set at the beginning of each iteration to the next integer in the sequence generated by the range function. Okay, because remember, we're going through a container. So a sequence is a container of values. The range function generates a container or sequence of integers over which the loop iterates. With one argument to the range function, and we'll talk a bit more about the range function later on, the sequence starts at 0. The argument is the first value not included in the sequence. So if you remember when we talked about doing substrings and slicing strings, it was from to. If you don't provide a from value, it would start at the beginning and it went to, but not including the value you put in is the second argument. A similar thing happens here with ranges. The value that's given, the range function goes up to, but does not include. So for I in range 5, print I prints 0, 1, 2, 3, 4. Okay, it prints 5 values, 0, 1, 2, 3, 4, but it doesn't print value 5. Okay, with 2 arguments provided to the range function, it starts at the first value and goes up to, but doesn't include, the second value. So it starts at 1, so this time we'd get print 1, 2, 3, 4. Okay, up to, but not including the last value. If you provide 3 arguments to the range function, we have our start value, our end value, but don't include this one, and then the third argument is how far you should step between each value. So in this case, we'd start at 1 and go up in 2. So we'd go 1, then 3, then 5, then 7, then 9. The next value we go to would be 11, but we're not including 11 as it's our upper bound of our range. Okay, so planning a for loop, print the balance at the end of each year for a number of years. So we've kind of got this idea of year equals 1, year less than or equal to the number of years, if that's true, update the balance, print the year and the balance, year equals year plus 1, loop back to the start. Okay, you've kind of seen this over and over and over again. We looked at this when we looked at while loops. Okay, to do this as a for loop for year in range 1 to the number of years plus 1, because if we go up to number of years, it doesn't include number of years in our range, right? It goes up to that value but doesn't include it. So if we go up to that value plus 1, then we will actually include the number of years in our range. We update the balance, we print the year and the balance. Okay, so this is kind of using a for loop, whereas previously we'd looked at using a while loop. Okay, so we've looked at an investment program previously, which worked slightly differently to this one. It used a while loop, and it worked out how many years it would take for us to double our money. This Python program uses a for loop, and instead tells us how much money we'd have after a user-specified number of years. Okay, so we define our constant variables, and we use the right formatting, so capital letters, rate equals 5, initial balance equals 10,000. And then line 10 asks the user to enter the number of years we're going to invest for. Okay, so maybe we invest for 15 years. Okay, we print the table of balances for each year, which is nice. So our balance is our initial balance. This is a variable, and we know it's going to change because it's in lowercase letters. And then using a for loop, we loop through the range starting from 1 and going up to the number of years plus 1. Okay, so it's going to include the number of years that we give it. So if we gave it 15 years, it's going to show us year 1, year 2, year 3, year 4, year 5, year 6, year 7, year 8, year 9, year 10, 11, 12, 13, 14, and 15, because number of years plus 1 would be 16, and we don't include that endpoint. Okay, and then it's the same calculation that we've seen before. Interest equals balance times rate divided by 100. Balance equals balance plus interest, and then a nice little formatted print statement of printing out the year and printing out the balance that the user has. Okay, so we've kind of got this format of setting up our variables, getting the input for the number of years we want to save for, and then our for loop, which does some calculation and provides some output. Okay, so here are some kind of simpler examples of for loops. For I in range 6 is going to iterate through the values 0, 1, 2, 3, 4, and 5. It does not do value 6. Okay. The loop will execute 6 times. It's going to execute, the first time it executes is for I equals 0. The second time it executes is for I equals 1. The third time it executes is for I equals 2, and so on. but it goes from 0 up to 5, not 0 to 6. For I in range 10 to 16, so we've given it 2 arguments. The first argument is the value we start at. The second value is the argument we go up to but do not include. So we'd go through 10, I would be 10, 11, 12, 13, 14, 15. The end value is never included in the sequence. For I in range 0, so we're going to start from 0, we're going to go up to but not include 9, and then the third argument is giving us the step. So how big a gap between each step. So we're going up in 2s. So we have I is 0, then I is 2, 4, 6, 8. The next step up of 2 would be 10, which is outside our range. Okay, so the third argument here is the step value. You can actually count down using the range function. So you could start at 5, go down to, but not including 0, and step down in -1s. So go down by 1 each time. So you'd go, I would be 5, then 4, then 3, then 2, then 1. Okay, so you can use a negative step value to count down. There are uses for counting backwards. Most of the time I would say people normally count upwards, but there are times where you might do a negative count. But the important thing is to keep it simple. There are times where you're going to want to count up in 2s, but I would have thought most of the time you're going to be counting up in 1s. Okay. This is kind of goes back to, and I think I talked about this in session 6, was off by 1 errors, right? So finding the correct lower and upper bounds for a loop. Should you start counting from 0? Should you start counting from 1? Should you use less than or equal to b or less than b as a termination condition? Okay, counting is easier for loops with asymmetric bounds. So if we look at both of these loops, they're going to be calculated or executed b minus a times. So we start off with I equals a, and in this one we start for I in range a, so we're starting at this a value, and we're going up to, this is going to cancel when we hit I equals b, right? Because if we're adding by 1 each time, we cancel when I is no longer less than b, and in this case we go up to but do not include b. So each of these is only run b minus a times. Okay. With symmetric bounds, okay, so using the equal to value, the loop is going to be executed b minus a plus 1 times. And that plus 1 is the source of lots and lots of errors. So if I equals 1 and we go up to I is less than or equal to b in a while loop, this is going to execute b minus a plus 1 times. That's a lot more noticeable in the for loop version, because in the for loop version we're going from 1 up to, but not including the number of years, plus 1. Okay, and that plus 1 here makes it a lot clearer how many times we're doing something, and where this b minus a plus 1 comes from. Okay. So quick summary of the for loop. For loops are very commonly used. The for loop can be used to iterate over the contents of any container, which is an object that contains or stores a collection of elements. A string is a container that stores the collection of characters in the string, and we looked at the range function creating a sequence of integers. A for loop can be used as a count-controlled loop that iterates over a range of integers. Lovely. Okay. If you know how many times you want something to happen, you typically use a for loop. If you don't know how many times you want something to happen, then you would probably are more likely to use a while loop. Okay, so some planning steps for writing a for loop or a while loop. You'll notice, I'm going to go straight away to it, section 7, or part 7, is implement the loop in Python. So if you're thinking about writing a loop, you probably do lots and lots of steps before you actually go and grab your computer and start typing out code. So the first thing is to decide what work are you going to be doing inside the loop. What work are you going to keep repeating, in theory repeating. Part 2 is then specifying the loop condition. How many times do you want it to happen, or why do you want it to happen, or when do you want it to happen? Part 3 is then determining the loop type. Are you going to be using a while loop? Are you going to be using a for loop? Okay. Part 4 is to set up the variables before the first loop. If you remember with some of our programs, you had to initialize variables or initialize some constants before the loop. Part 5 is then to process the results when the loop is finished. So let's say the loop runs to its completion. what are we doing with the results from the loop? How are we processing that? What are we doing? And then part 6 is to trace the loop with typical examples. So actually run through the loop, maybe by hand, with a typical set of data and see if it works or functions the way you think it should. And if it does, and you've tried it with a couple of typical examples and you're happy, then you go on to coding, part 7. Then you get your Python program out and you start implementing the loop in Python. Okay. We're now going to move on to probably the hardest topic I think we've talked about so far, and that's nested loops. Please, at this point, really pause the video, go grab some paper and a pen, because if you have a paper and a pen, you're going to be able to do this so much more easily than just trying to read through the code. So let's say I have this image, right? How am I going to print out a table with rows and columns where I have, you know, values for x to the 1, x to the 2, x to the 3, x to the 4, and then I'm going to 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 3 to the 3, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, and so on, right? So I'm going to use a for loop. I'm going to be printing this table body. How many rows am I going to need? How many columns am I going to need? Well, I'm going to need 1, 2, 3, 4 columns. And how many rows am I going to need? Well, I'm going to need I'm going to need a row for 1, a row for 2, a row for 3, blah, 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 up to a row for 10. And the way we're going to actually do this is we're going to loop per row and then loop per column. Okay. So we're going to have a loop per row and a loop per column. So as a flowchart for this, using a nested loop, we're going to start here, right? We're going to start at this row and at this position. X equals 1. Is x less than or equal to 10? Yes, it is. We're going to set n to equal 1. Is n less than or equal to 4? Yes, it is. Print x to the n. So we get 1 to the 1, which is 1. We then increase n by 1, so n is now 2. And we go back to the start of this loop. N is less than or equal to 4. So 2 is less than or equal to 4. That's true. We print 1 to the power of 2, which is 1. And then we increment n. So n is now 3. We go back to the start of our loop. 3 is less than or equal to 4. This is true. So we print 1 to the power of 3, which is 1. We then increment that n. So n gets incremented from 3 to 4. We go back to the start of our loop. Is 4 less than or equal to 4? Yes. So we print 1 to the power of 4, which is 1. We then increment n, so n increments from 4 to 5. We go back to the start of our loop. Is 5 less than or equal to 4? No. So we exit this inner loop and print a new line. We then increment x. X was 1, now x is 2. We go back to the start of our loop. Is 2 less than or equal to 10? Yes. We set n equal to 1. Is 1 less than or equal to 4? Yes. So now we're printing x, which is 2 to the power of n. N is 1. 2 to the 1 is 2. We increment our value of n. N is now, it was 1, now it's 2. And we go back to the start of our loop. 2 is less than or equal to 4. This is true. So we print 2 to the power of 2, which is 4. And we increment our n. Okay, so this keeps happening and happening and happening until n equals 5. At which point we exit the inner loop to go back to the outer loop, which prints a new line and increments our value of x, increasing it from 2 to 3. This process of going back into the inner loop, doing something about four times, exiting that inner loop, incrementing x happens over and over and over and over again until x is greater than or equal to 10, in which case this condition becomes false and we exit. Okay. So, as a program, I will try and identify kind of the key areas, but again, maybe pause the video, copy this down, have a little read. This Python program implements this nested for loop to produce a table similar to this. Okay. So the first thing it does is it initializes the constant variables for the max ranges. So n max is the powers, and we're going from powers of 1 up to powers of 4. And x max is the number of values we're going to be doing, and if you look at this table, we're going to be doing from 1 up to 10. Okay. So the first thing we're doing is going to print the table header. We're going to use a for loop. It's going to go for n in range 1 to n max plus 1. nmax is 4, so we're going to go from 1 to 4 plus 1, which is 5. So from 1 to 5, but not including 5. So we're going to go for n values 1, 2, 3, and 4. Okay, and then there's a little print, which prints the value of n. This end equals empty string parameter is used to stop the print statement printing a new line, which will be useful. So all of these n values are going to be printed on the same line. Okay. Line 13 prints a blank line. Line 14 for n in range 1 to nmax plus 1. So again, from 1 to 5, not including 5, we're going to print x. And again, we're going to end with a... we're going to use this end equals empty string parameter to stop the print function creating a new line. And then we're going to print a new line with an empty, a little bit of empty space. These are just spaces. And then a series of hyphens, 35. Okay, and then we get onto the table body, which is the kind of detail here, right? So we're ignoring this bit now, we're just doing this bit. And the table body is based on doing these nested for loops. Okay, so we have the outer loop, which goes for x in range 1 to x max plus 1. So x max is 10, so from 1 to 11, but not including 11. Okay, so it's going to do this outer loop of x equals 1, kind of this the bits in green, right, with the green lines. Okay, print the x row in the table, so then this is the inner loop for n in range 1 to n max plus 1. So from n max is 4, so from 1 to 5, but not including 5, so the values of n, 1, 2, 3, and 4. Print 10.0f, so format specifier %n to the power of x to the power of n. So this does our x value and raises it to the power of n. It does this calculation here, x to the power of n, and then prints that out and doesn't create a new one. Okay, so this is this section here, 22 to 23. 22 to 23 is this this inner purple section, the inner loop. And then 20 to 25 is this outer blue bit, or teal section. I guess it's this loop condition, this print line condition, and this increment of the x value. Okay. So pause the video, copy this down, run it, and it should produce a table which resembles something similar to this. Okay. Again, if this is very, very confusing for you, and maybe doesn't seem to make much sense, and you're not really sure how to run through this inner, this nested loop section, grab a piece of paper, write down your table of x value and n value, and just run through this and fill it out. Okay? And you'll see how the x value changes, you'll see how the n value changes, and you'll see where each print line is, okay, these print lines here, for what's being outputted at each stage. And that will make the loop within a loop make much more sense. Okay, so here are some common nested loop examples to kind of give you an idea of how nested loops work, again, in a slightly easier format than this one, without all the specifiers. Remembering, again, I'm just going to highlight it, end equals the empty string is a parameter to prevent the printing of a new character line. Okay, so how does this first one work? So for I in range 3, so for I being the value 0, 1, then 2, and for j in range 4, so j ranging from values 0, 1, 2, and 3, print an asterisk without a new line. Okay, so initially I is set to 0, j is set to 0, and we print an asterisk. Then j is set to 1 and we print an asterisk. Then j is set to 2 and we print an asterisk. Then j is set to 3 and we print an asterisk. This j loop is now finished, so we print a new line and go back to the start of our I loop, which increments I from 0 to 1. We then enter our j loop, and j goes from 0 to 3, so 0, 1, 2, and 3, and prints an asterisk each time. So it prints one asterisk when j is 0, another asterisk when j is 1, another asterisk when j is 2, and another asterisk when j is 3. This j loop is now finished, so we exit the j loop, and we move on to the next line of code, which prints a new line. We loop back to the start of our I loop. I was 1, I now gets incremented to 2. And we enter our j loop again, j gets set to 0, we print an asterisk, j gets set to 1, we print an asterisk, j gets set to 2, we print an asterisk, j gets set to 3, we print an asterisk. This j loop is finished, so we print a new line. We go back to the for loop, I was 2, so it's finished with its range, and we exit. Okay, so what this actually does is it prints 3 rows of 4 asterisks. Okay, the j loop here is telling us how many asterisks to print, 4 of them. We print a new line after printing out 4 of them, and we're repeating this 3 times. Okay, so we print 4 asterisks, a new line, and then we repeat that 3 times. Okay, if you look at that compared to example number 2, so for I in range 4, so I is going to go from the values 0, 1, 2, and 3. J in range 3, so J is going to go for the values 0, 1, and 2. Print an asterisk, again, new line character, and then print a completely new line, right? This has no argument given to it. An empty print statement will just print the new line. So I get set to 0, J gets set to 0, and prints a... J gets set to 0 and prints an asterisk. J gets set to 1 and prints an asterisk. J gets set to 2 and prints an asterisk. The J loop is finished. We print a new line. I get set from 0 to 1. J gets set to 0, print an asterisk. J gets set to 1, print an asterisk. J gets set to 2, print an asterisk. The J loop is finished, print a new line. I get set from 1 to 2, and so on. Okay, so this is going to print 3 asterisks, then a new line, and it's going to repeat that 4 times. So we have 4 rows, 1, 2, 3, 4, of 3 asterisks each. 1, 2, 3. Okay, if you look at this bottom one, this is probably where it gets more complex. For I in range 4, for J in range I plus 1. Okay, print an asterisk, don't print a new line, and then once this J loop is finished, print a new line. So initially, for I in range 4, I is going to range from the values 0, 1, 2, and 3. So initially, I is set to the value 0. For J in range 0 plus 1, because I is set to 0, so for J in range 1, so 1 time, J gets set to 0, prints an asterisk. The J loop is finished, so we print a new line, and we increment I. I goes from 0 to 1. We enter the J loop. For J in range, I is now set to 1, so 1 plus 1. So for J in range 2, print an asterisk and end. So J gets set to 0 and prints an asterisk, J gets set to 1 and prints an asterisk. The J loop is finished, we print a new line. We go back to the for loop, I was 1, it now gets incremented to 2. We enter the J loop. For J in range, I plus 1, I is 2, 2 plus 1 is 3. So for J being the values 0, 1, and 2, print an asterisk. So we print J is 0, we print an asterisk, J is 1, we print an asterisk, J is 2, we print an asterisk. The J loop is finished, we print a new line. I gets incremented from 2 to 3. For J in range I plus 1, so I is 3, 3 plus 1 is 4. So for J being the values 0, 1, 2, and 3, we're going to print an asterisk. So J is 0, we print an asterisk, J is 1, we print an asterisk, J is 2, we print an asterisk, J is 3, we print an asterisk. This J loop is finished, we print a new line. The I loop is finished, we exit our program. Okay, so this is going to print 4 rows. This is what this 4 is telling us. And the rows are going to be size 1, then 1 plus 1, so size 2, 2 plus 1, size 3, 3 plus 1, size 4. Okay, as the I increments. Okay. Some more examples for I in range 3, for J in range 5. If J divided by 2 is 1, divided by 2 with remainder is 1, so what's the remainder? It will print an asterisk. If it's not divisible, if it's divisible by 2 perfectly, it will print a hyphen, and then end. And then it will print the new line. Okay. So I get set to 0. It's going to go through 0, 1, 2. We're expecting it to have 3 rows. For J in range 5, so we're expecting 5 things to be printed out. J is initially 0. 0 divided by 2 is 0, so it has no remainder, so we're going to print out a hyphen. Okay. Then J gets set to 1. 1 divided by 2 with remainder is 1, so we print out an asterisk. Then J gets set to 2. 2 divided by 2 is 0, so we print out a hyphen. Then J gets set to 3. 3 divided by 2, the remainder is 1, so we print out an asterisk. And then J gets set to 4. 4 divided by 2, the remainder is 0, so not 1, so we print a hyphen. This J loop is finished, so we print a new line. Okay. Then the I increments, and we go back into the j loop starting from 0 again. So what we're going to end up printing is a hyphen, then an asterisk, then a hyphen, then an asterisk, then a hyphen. Or dashes, as they're being called here. Okay, in the second example, we've got the same thing. We're going to have 3 rows. Each row is going to have 5 characters in it. If I is divisible by 2... Oh, okay, so I gets divided by 2 with remainder, and we compare the remainder of I with the remainder of j when it's divided by 2. If they're the same, we print an asterisk. If they're different, we print a space. Okay, so I gets set to 0, j gets set to 0. 0 divided by 2 is 0, there's no remainder. J divided by 2 with remainder, j is 0. 0 divided by 2 with remainder is 0. So 0 is the same as 0, so we print an asterisk for the first case. Then j gets incremented to 1. 0 divided by 2 still gives remainder 0. 1 divided by 2 gives remainder 1. 0 does not equal 1, so we print a space. J gets incremented to 2. 0 divided by 2 gives remainder 0. 2 divided by 2 gives remainder 0. These are the same, so we print an asterisk. Okay. J gets incremented to 3. 0 divided by 2 gives remainder 0. 3 divided by 2 gives remainder 1. 0 does not equal 1, so we print a space. And then j gets incremented for its final time to 4. 0 divided by 2 gives remainder 0. 4 divided by 2 gives remainder 0. 0 is the same as 0, so we print an asterisk. Okay, this j loop is now finished, so we print a new line. So what we've ended up doing is printing asterisk, space, asterisk, space, asterisk. And then we increment I to be 1. We enter our j loop, j gets set to 0 to start with. 1 divided by 2 gives remainder 1. 0 divided by 2 gives remainder 0. 1 does not equal 0, so we print a space. Okay. Then j gets incremented by 1, so j is now 1. 1 divided by 2 with remainder is 1. 1 divided by 2 with remainder is 1. 1 is the same as 1, so we print an asterisk. J gets incremented to 2. So I is 1 divided by 2 gives remainder 1. J is 2. 2 divided by 2 gives remainder 0. 1 does not equal 2, so we print a space. Okay, and this repeats through the j loop. We print a new line, and then it repeats one more time for I is 2, and then j is 0, 1, 2, 3, 4. Okay, and this will overall print a checkerboard pattern. Here is kind of a long example, but an example which shows kind of how useful loops inside loops can be, and also mixing and matching while loops and for loops. Okay, so what this is going to do is it's going to calculate the average. This program computes the average exam grade for multiple students. Okay, so the first thing it does is it obtains the number of exam grades per student. So how many exams have the students sat? So num exams equals int input. How many exam grades does each student have? We use a non-sentinel value. We're going to initialize more grades to a non-sentinel value so the while loop runs. This could be done using a Boolean, but here they've set it to a y for yes. So while more grades is the same as y, so this is true. We enter our while loop. We enter the exam grade for the student. We set our total to 0, so we're initializing our variable. For I, in range 1 to number of exams plus 1. So if they did 4 exams, this is going to go from 1 to 5, not including 5. So it's going to loop 5 times. It's going to print a loop the number of exams times the students have done something. So 1, 2, 3, 4. Score equals input exam %d %i. So this is going to print exam 1 and wait until the user has inputted the score. It's going to add that onto a tally. Okay, this is kind of like the summation stuff we looked at in session 7. So we're looking at summing up their scores. Okay, so this for loop repeats until we've entered all of the exam scores for a single student. It then computes, the for loop then exits and moves on to the next line of code, which computes the average. So it computes the total divided by the number of exams they sat, and prints out the average is whatever the average is, to 2 decimal places. Okay. It then asks the user, do they want to enter grades for another student? So more grades equals input, enter exam grades for another student, yes or no. They enter a value, either y or n, hopefully, because they've been prompted to, and more grades gets converted to an uppercase version of that letter. If they enter an uppercase Y, we come back to the start of the while loop, and more grades will still be a capital Y, and we'll enter this inside loop again, which is going to ask them to enter a bunch of exam grades for a single student. If the teacher is finished with exam grades for all students, they can type in an N. We set more grades to an uppercase N. When we go to check the while loop, capital N is not the same as capital Y, so we exit the while loop and exit the program. Okay, so as a summary of the types of loops we've looked at, there are two types of loops we've looked at, while loops and for loops. While loops are very commonly used, they're really general purpose. For loops can be used to iterate over the contents of a container, and can be used to do a count-controlled loop that iterates over a range of integer values. If you know how many times you're doing something, you might use a for loop. If you don't know how many times you might be doing something, you'll probably use a while loop. A while loop requires the following steps. So you need to initialize or set up the variables to start looping. You need your condition, so testing if you should exit the loop body, and you need an update. Something should change each time you run through the loop. Or there should be the possibility of changing each time through the loop. A loop executes instructions repeatedly while the condition is true. We need to be really careful of infinite loops as well as off-by-one errors. That's a common error that happens when using while loops. Think through a simple test case to avoid this type of error. So think through, maybe try running it by hand with a smaller test case just to make sure you are running it the correct number of times. A sentinel value denotes the end of a data set, but is not part of the data. We typically use these to for the user to give an indication that they finished entering data of some sort. You can also use a Boolean value to control the flow of a loop. You set the Boolean value to true before entering the loop, and then set it to false to leave the loop. These sometimes are flipped around, and we set the value to false, but then we use a not Boolean value. So, for example, have I found the value yet? I might set to false, and my while loop would be while not found. Okay, and then when the body of a loop contains another loop, the loops are called nested loops. A typical use of nested loops is printing a table with rows and columns. We've also just seen how we could use a loop within a loop to do exam averages for multiple students. Okay, so that was the end of loops. Our next series of sessions are going to cover functions. I hope this has been useful. The next thing you guys should do is either pause the video, rewind it, and look at the code and copy it down and try it yourself, or go and do the programming tasks associated with this session. Otherwise, we will see you for the next session, which will be about functions.